when you add 3/5 plus 2/5, effectively the fifths becomes a unit. We have like 3 equal parts plus 2 equal parts equals 5 equal parts. So if we add 3/5 plus 2/5, we get 5/5, right? So why doesn't the same happen when we say multiply? When we do 3/5 times 2/5, why don't we think of this as 3 equal parts times 2 equal parts equals 6 equal parts, right? Like this is clearly not right, but why is this not right? Right? It's not a very intuitive thing. We really have to think about like what these symbols really are representing here. So addition, we are sort of combining things, and multiplication, when it comes to this, we really have to think of this as go back to our like understanding of what multiplication is, where like A times B is A groups of size B. So this is 3/5 of a group of size 2/5. Okay, so what we first have to actually do in understanding this multiplication problem is represent 2/5, because we want 3/5 of a group of size 2/5. So let's make our groups first. So our group will have size 2/5. So over here I have highlighted 2/5 of a square. So this is going to be our group, and so we want 3/5 of that. So we want 3/5 of 2/5. So what we can do is break all of these equal parts into 5 equal parts, right? And when we do so, we get this picture right here. And if I want to take 3/5 of two of these equal parts over here, each of these equal parts, if I want 3/5 of them, we've split it into 5 equal parts, and then we just take 3 of them. Okay, so now we have 3/5 of the 2 equal parts, and we're left with this. And what is this represented by in a number? Well, we have 2 times 3 of these equal parts. And how many equal parts make up our whole rectangle? Well, we have 5 times 5. So 5 times 5. So this is equal to 6/25. Okay. Let's do like one more, just where the denominators are different. So what if we want to do 1/3 times 2/5? So again, you can represent 2/5, and then you want to take 1/3 of this 2/5. Okay, so we break each of these fifths into 3 equal parts, like so, and then we just take one of those 3 equal parts for each part that we have. So we've split one of the 2/5 into 3 equal parts, and then we take one of them, and then we do that for the other. And then we are left with 1 times 2 equal parts out of 3 times 5, which make up the whole rectangle. So we're left with just numerator times numerator equal parts, and how many equal parts make up the whole? It's just going to be the denominator, the product of the denominators. So 3 times 5, which is 15. Okay. What about when it comes to multiplying mixed fractions? So 2.5 times 3 2/3. So these pictures could get very complicated, and so we sort of have to draw a line with how complicated we allow them to sort of get here. So 2.5 times 3.5. I am saying that my one square right here represents my whole, and so if I have 2.5 groups of size 3 2/3. So one group is represented by 3 2/3 of a square. So here I have 3 2/3 of one square for my top row. And then I take 2.5 of those of those groups. So this is one of those groups. This is the second of those groups. And then here is half of one of those groups. So we have 2.5 of them. And so now we kind of go through and we can sort of just count things and look at sizes of everything to figure out what this product is equal to. So in the middle here, this is just 2 times 3, so that's 6. This right here, this part right here is just 1/3 of a square, so this is 1/3. And then we have 2 of them right here, and then 2 more right here. This is half of a square, this is another half of a square, so we have 2 times a half total, or 3 times a half rather, forgot to count that one. And then right here in the bottom right, this would kind of, to understand this, we would have to kind of understand like this picture like up here, but really this is just going to be half of a third or a third of a half, however you want to think of it. So 1/2 times 1/3 is a 1/6, and we have 2 of those there. So adding that all together, we have 6 plus 3/2 on the bottom, plus 4/3 in the top right, plus 2/6 in the bottom right. And so we could add those all together, get like common denominators and stuff like that. So let's use a common denominator of 6, I guess. So 6 plus 9/6 plus 8/6 plus 2/6 is equal to 6 plus 17, 18, 19, 6. And this is 9 1/6. Okay. All right, cool. We could be a little bit more general here. So one thing to make sure that you don't do when you're multiplying these things is to do something like 2.5 times 3 2/3 is equal to 6 2/6, where you multiply this number times this number and then multiply the fraction times that fraction. So you can see very clearly from like this and this picture that like this is not the correct answer. But like, why is that? Like, what's going on? Well, the reason is because like implicitly, like there's like a distributive rule going on here, or distributive law. And there's like little pluses in between like the 2 plus 1/2 and the 3 plus 2/3. So you could represent this as like 2 plus 1/2 and 3 plus 2/3, and then get like the same sort of picture that we used for something like 25 plus times 32 or something like that. So this is like 20 plus 5 and times 30 plus 2, and then each of these rectangles is going to be like, this will be like 5 times 30 in the top right, in the top left it'll be 20 times 30, so on and so forth. So in here we would have 6 right here, 2 times 2/3 would be 4/3, 3 times 1/2 is 3/2, and then 2/3 times 1/2 is 2/6, and then add everything up the same way that we did before, right? Okay, so enough of that. Moving on to division, which is also fairly complicated. There aren't as many like great clear pictures for division. So let's first start off with the following. So if I want to do 6/13 divided by 2/13, so when the denominators are the same, this becomes a little bit easier to deal with, because 6/13 divided by 2/13, we're really just asking how many groups of size 2/13 go into 6/13. So 2/13 times what is equal to 6/13. So we can see that if we had 3 of these, we would have 3 times 2/13 is equal to 6/13. And so this should be equal to 3. Right? And it's equal to 3 for the same reason that like 6 divided by 2 is equal to 3. Right? So like the denominator here doesn't really affect this problem, assuming that the denominators are the same. 6 6 divided by like blah, and then divide that by 2 out of the same blah, like is always just going to be equal to 6 divided by 2. Same would have been true if I had like 8/17 divided by 4/17. It's just going to be the same as 8 divided by 4, right? When you have something like this, though, where the fractions do not have a common denominator, what we normally do is invert the fractions and multiply, right? But this is a very weird thing to do, and if you ask most people like why this is the thing that you do, they would probably have no idea like how to answer that, right? Well, here's why. One thing that you could do is just translate this to the above problem, or like something similar to the above problem, where there's a common denominator. So we find a common denominator first. So let's just use a common denominator of 7 times 8. So converting 6/7 to a fraction with the denominator of 7 times 8. This is 6 times 8 over 7 times 8. And then divide that by 5 times 7 divided by 8 times 7. And so all of a sudden we have 6 times 8 divided by 5 times 7. And the denominators are the same, so again we can ignore them. So this is 6 times 8 divided by 5 times 7. And I'm just going to write that like this. So 6 times 8 divided by 5 times 7, which is the same as, let me write that as, 6 over 7 times 8 over 5. Okay, so these just happen to be equal by no coincidence, and again, by no coincidence, this is exactly what we get if we invert and multiply, right? So this is why the invert and multiply strategy actually works. Okay. Now pictures are good sometimes when you can kind of find a way. Here's another visual way to see why invert and multiply is the right thing to do. So 2 divided by 2/3, what would that be? So let's first do 1 divided by 2/3. So to know 1 divided by 2/3, we're asking how many groups of size 2/3 go into 1, or vice versa. If we want to do like a how many in each group thing, whatever. So, okay. So we have 2/3 of a square shaded in right here. And how much of this 2/3 do we need to fill up the entire square? Right, so 2/3 times what gives me 1. So we know that the answer will be 3/2, and the reason why that is true is because, well, to fill up this entire rectangle, visually you can see that we just need 3 of these squares right here. So we need, or those rectangles. So we need 3 of those rectangles. And how big is each of those rectangles? Well, each of those rectangles, in relation to the 2/3 that we're starting with, each of these rectangles is half of the shaded part. So each of those rectangles is 1/2 of the shaded region right here. And so we need 3/2 of this shaded region to fill up the entire square. Okay? And so to translate this to 2 times, or divided by 2/3, to fill up 2 of these squares, we would need 3/2 times 2 to fill up 2 of the squares. And if we wanted to fill up 3 of the squares, we would do 3 times 3/2. And so really what we're doing there is just inverting 2/3 to become 3/2, and then multiplying it by whatever this number is right here. And you could extend this to like fractions of, like, if you wanted to have like 2.5 times 3/2, or 2.5 divided by 3 or 2/3 or whatever. Can't talk, but it would be like the same sort of thing, and it would really just follow like this whole pattern. So invert and multiply is the right thing to do, and there are ways to see why it's true. It just kind of takes a little bit of time to wrap your head around it sometimes.